So you're here hopefully for Earth Engine 101, like haven't done Earth Engine before or did it at a previous kind of meeting but really haven't experimented with it much on your own and need a refresher. This is going to be kind of a slower paced to as much as we can 3-hour session. So we're going to do 90 minutes, then there'll be a break, and then there'll be 101B after that. So if you actually have done Earth Engine in the past and you know how to map a function over a collection and you feel confident with that terminology and think you could do it, then you probably would want to go to 101B, which is going to be a little bit more advanced with the concepts. But if that doesn't make any sense to you, then you're in the right place, right here. So, all right. My name is Tyler Erickson. I'm what's known as a developer advocate on the Earth Engine team, or I focus primarily on the Earth Engine product in addition to a few other ones. And I'm a little bit about my background is like I came from academia before joining Google about 6 years ago now. And so I view this as like a tool that is supporting what I used to be before I came to Google. People that are developing algorithms, they do some coding, but you need a tool to make it easier to manage a lot of data. I'm going to start off this today by going through a bit of an overview of Earth Engine that Matt did during the opening kind of introduction, but expand on that. So that's going to probably take around 20-25 minutes to just do slides, a broad overview of what Earth Engine is, a little bit of what it's been used for before. But then we're going to go into hands-on. For the majority of this time, it's going to be following along. We're going to be scripting starting from nothing and building our way up to hopefully, doing some amazing classifications on the continental scale. So without further ado, I'm going to start off into the slides. I'd like to introduce a few of the TAs in the back. We got Tanya and Renee. At least there might be others. If you have any questions as we're going along, please raise your hand and they'll come and help you. That doesn't apply to the people that are watching the recorded video of this, but I wanted you guys in the room to know that as well. We are recording this. So when you answer or ask questions, I'm going to be trying to repeat them so we have a good recording of it. And you will be able to listen to your questions, I guess, later on. You'll get to see this again in the future. So with that, I think I will embark just on the slides. And since we have a relaxed kind of pace of 3 hours, we normally cover this in about 90 minutes to 2 hours, so we have a more relaxed pace today. Feel free to interrupt me and with a show of hands whenever something is confusing and you want me to repeat, go into more depth on something. We do have time for it. All right, so Earth Engine itself, if you don't know already, is our cloud-based platform for earth science data and analysis. It's trying to help out with the idea of managing a lot of geospatial data. So whether it's remote sensing data from satellites, airborne, it might be digital elevation files, it could be weather or climate forecasts of the future. This is a platform that we're trying to make a lot of the painful IT things easier to do. So you can focus more on actually just getting results, either developing new scientific algorithms that you want to publish or also transitioning those into operational research. So take something from a paper and then make it run, on all the new data that's coming forth. That's what Earth Engine is about. In order to make this possible, we are co-locating a lot of geospatial data in our data centers. We're in the order of 10 to 20 petabytes, depending on how you count it now. It gets to be too much to kind of worry about how big it is right now. It's a lot of data. And we keep adding to it week after week. We also have a lot of computers that are put next to that data so they can do fast computations on it, and we will size that cluster up and down depending on how much demand we have for it. And then finally, we expose that to users through APIs. And so there's a JavaScript and a Python API. We're going to be using the JavaScript API today in order to work with Earth Engine. And I'm also going to be spending a lot of time with a tool that we call the code editor, and that works with the JavaScript API to make things easier to do. We use it for teaching, because it makes a lot of things about teaching Earth Engine a lot easier, but just realize that when you're going through this, the same techniques that we have, the same underlying Earth Engine is available through a Python API too, if you come from that type of background. Like myself, I'm more of a Python programmer by background. The Earth Engine data catalog is pretty vast and growing. It started off with the Landsat collections. We were trying to focus initially on deforestation in the Amazon, and the Landsat collection was free available data at that point, public domain data. And right when the Landsat program announced that their data was going to transition from a $600 per scene cost to being free data in 1998, we actually went through and sorry, I got the wrong date there. Anyway, about 10 years ago, we went in the next year, started up the Earth Engine projects because it was a large source of data that we needed a way to enable people to work with that volume of data. So it started off with Landsat, but we've gone into many other data sets since then. In recent years, the Sentinel collection from the European Union, ESA, and the ESA is the one that distributes that, has been a huge kind of feed that we are ingesting into Earth Engine. So they are producing a massive amount of terabytes of data each day, and we try to make that available, and a lot of other feeds as well of different data sets. Our data catalog is largely governed by use cases that are presented to us by users, so we're not trying to mirror everything under the sun. It's basically like people will say, we need this data set to do this particular use case, and we're like, that looks good, and we prioritize it versus all the other requests and keep adding more and more to our data catalog all the time, the public data catalog. In addition, you can upload your own private data, but what we're going to be working with all today is the big public data catalogs that are already available in Earth Engine. So we'll go into a few of these as we go through today, but I want you to know it's a lot more vast than just the couple of data sets that we're going to touch on during this hands-on workshop, and it keeps changing. In addition, we have a lot of geospatial processing primitives, so what you can do with the data that's in Earth Engine. So we have the concept of an image that you might want to manipulate, look at the different mans, do math on it, clip images, work on collections of images, which we're going to do today. There's also the vector equivalent of features and features collections. And for any of these large collections, you may want to filter them by some type of metadata, whether it's spatial, temporal, something that's actually in the metadata of the feature or image, and then also reduce that large amount of data by some dimension, whether you're going to aggregate in space or time or something else. We have reducers. We have the concept of SQL joins, sort of, joining two data sets together, and that also could be joining in space or time or by some type of metadata. And then more advanced things we have like kernel convolution type of operators that actually can aggregate in complex ways this data that you've joined together. We do give you ways to export out of Earth Engine because at the end of the day, you might not be able to get your entire analysis into Earth Engine, so we want to make sure that you can stop at any point where we can't actually support your use case and get it out of Earth Engine into another tool to work on it. And in addition, we are continuing to work on incorporating advanced machine learning algorithms into Earth Engine. A lot of these we've had in Earth Engine for a while, like cart random forests, sport vector machines, but we're moving into more of the deep neural nets, like TensorFlow type analysis on the data as well. And then one of the basic things that's really great about Earth Engine is you don't have to worry so much about these projections. Like if you've worked with geospatial data before, you realize that there's hundreds, if not thousands, of projections that you can be delivered the data in. And we do a lot of that reprojecting on the fly, so you don't have to worry about it if you don't want to, or you can actually really specifically control how things get reprojected if you do care about managing the projections. So we have about 1,000 of these different kind of concepts, whether they're methods or in general classifications, these objects, and that is growing all the time as well. So if you really get into the cutting edge of Earth Engine, you want to look at our API release history. Like every time we push a new release, we'll say, hey, this changed. We added this new data set. We added this new feature. We announce those often on the developers list as well. So there's a lot of stuff that you can do with the data. For a concrete example, this is a typical satellite image for a certain part of the world. I think this is down in South America. But the fact of working, especially with satellite data, optical satellite data, is it's noisy. There's clouds, there's shadows. Even if you don't have something as blatant as this, there's going to be some atmospheric effects. We try to give you algorithms that you can start working with large amounts of data to get rid of a lot of that noise. Do that type of processing, whether it's directly filtering the clouds and shadows or fitting models that will smooth out those type of impacts over time. So you can start focusing on what is happening on the Earth's surface rather than the artifacts that you're seeing by looking at it from satellites. We do this at a large scale. This is before we would do this type of processing. We used to have cloud-free mosaics that included quite a few clouds as you look at the northern part of South America. But if you put together enough of the Landsat data and Sentinel data and MODIS data together, you can blend it to make things that are like this, which is the pretty Earth composite that you see right now as the base map of Google Maps and Google Earth. That was something that was produced in Earth Engine. We can do that globally, but it's not just these type of visualization outputs. We allow people to like derive their own properties. You know, if you're looking for something like water, surface water changes or deforestation where it's happening, you can look for those particular land cover changes in Earth Engine and make your own maps at this type of scale. A lot of what we're going to be focusing on today is the code editor, and this is, once again, this is a GUI application that sits on top of Earth Engine, and we use it for education or training. And we get people started on here because there's a lot you can do with it, and it's customized for, you know, starting to build these Earth Engine applications. It's probably not what you want to go and give to a decision maker like this. They're going to be a little bit overwhelmed by the interface that we have here, but it's for building algorithms. So it's a good place to start learning about Earth Engine in here. And we're going to go through the different aspects of it when we get into the hands-on section, but I just want to give you at least a brief overview right now. We have a map output that you can get your results, whether it's vector or raster imagery on layers on the map. We have a coding interface in the middle there, and then we have all kinds of documentation and management of your assets on the upper left, and a lot of inspection debugging tools over on the right. So that's kind of a general outline of what we're going to be playing with a lot today, and then we're going to work through particular aspects of the user interface as we go through the tutorial. So at the end of the day, though, you can produce apps that don't expose all of that. You can kind of hide that from your users that may not be programmers or don't need to know about the details of the algorithm. There is another class that I'll put a plug for that is user interfaces in Earth Engine, which I can't remember which day it's going to be taught. It's not today. It's going to be one of the following days. And that's if you are trying to use Earth Engine to encapsulate like an algorithm or data set to share with others that don't have access to Earth Engine. That's probably one of the classes that you want to go to. So that's sort of a powerful aspect. You start in the code editor to do that, but you can make an end result that you don't need to be in the code editor to actually be sharing this with others. And finally, I wanted to just show one kind of concrete example of a group that started learning Earth Engine with the code editor, but then they went off and used the Python API and the JavaScript API and all kinds of other tools of web development to make a pretty neat app. And if I break out of my slides here for a second to just go live to their application, this is an application that gives you a summary of land cover types. There's quite a few of them in here over the last, try to figure out how many years it is. Since 1984, so we're looking at 35 plus years there, and it allows you to go in and look at all of these properties, how they vary in the United States, and overlay it with some interesting features that might have affected land cover. So in this case, I guess I shouldn't be doing red on red. That's a little bit hard to see. So let's go back to another one here. Oh, another red one. There we go. Okay. So this is a perennial cover, one of the land cover classification apps, or land cover classification classes. And I've overlaid on that fire boundaries from some database. I can't remember exactly which one they were drawing this from. But then you can see areas where you would expect a land cover change to occur. I'm zooming in an area that in 2002 burned extensively. It's called the Biscuit Fire in Oregon. And one of the things you can do with this app is like draw features on it. It allows you, a user, to kind of like specify areas they're interested in, for example, something like that. And then you can go ahead and look at the time series for that particular polygon that I drew on. And in this case, you can see one of the land cover classes as you're going across here, tree cover, it dropped precipitously around 2002. That's when that occurred, that fire occurred. And then after that, you have some responses of the other land cover types. So this is live going to Earth Engine to generate all the data for this graph as you draw that polygon and say, go get the end result. So it's kind of a neat example of working with a lot of data and then also allowing the user to go through a user interface here, draw a polygon, and actually get something customized for an area that they're interested in. It also allows you to go through and like generate reports. So I'm going to let that report generate. And in this case, the report is a PDF file that it downloaded for me. And it kind of just encapsulates that into a PDF. So it's something that you can then send around if people are more interested in seeing a static representation of it. Excuse me there. All right, so let's go back into our slides here for a little bit. Oops. That did not go into my slides again. All right, so that was the app. Now let's back out a little bit now that you've seen an example, kind of an end result, and go over again kind of what the main things that Earth Engine can do, the Earth Engine backend, what you can do through the API. What?
Before we move on,
sure.
Just occurred to me, is there also a library of apps like that that have been developed? I mean, you talked about the data library.
So we're hoping that, well, not this app, but if we back up to these apps right here, this was just launched last week. So not yet. We're hoping that actually occurs, but this type of user interface app it's one that we hope to grow, and we have a catalog of those, but it doesn't exist yet. There's some example apps, but that's as far as we got. In terms of things like this that external groups have built on top of Earth Engine, we tend to feature them a lot on our Medium blog. We'll blog about something that comes out. But we can't keep up with all the people that are publishing papers on it, so it's just kind of just a select sample of those at this point. Any other questions before I cruise ahead? Thanks for the interruption, too. I do like those. All right, so what can Earth Engine do? One of the basic uses people use it for is to just get one particular image, because our interface for selecting in space and time can be more convenient than going and getting the original image from one of the data providers, especially if you work with lots of images and you want to do this repeatedly. So what you can do is say, I want this collection and I want to select something in particular in space and time and just give me that one image. And if you know the original ID of an image, like from Landsat or Sentinel, you can specify that as well. And so it will give you an image back. It includes all of the original metadata, so you have projection information for all of the different bands. The bands are in their original projection and data type, so there's not going to be much loss from the original file that you might have downloaded from the provider. You're getting all of that metadata and you're getting all of the band information within there. We then allow you to take an image like that and apply algorithms to that. So you can chain a bunch of these algorithmic primitives to an image. So you might want to do a band ratio. If you're familiar with remote sensing, usually whenever you start a remote sensing class, you learn about NDVI and how do you do a comparison of the near infrared band to the red band. And we're going to do that in our tutorial as well today. But that's an example of an algorithm that can be applied to an image. And that's just the starting point. They can be a lot more complex than that, but we can basically take these descriptions of algorithms and apply them to images. We can also start with a collection and then filter a collection down. So when I mentioned before how to get an image, you might start with an image collection of like all the Landsat 8 data that has been collected by that platform, and then filter it for your particular location, and filter it in time, and then filter it maybe by cloudiness, which is a piece of metadata on the image. So you can do a lot of filtering there to just get a collection of images that you want to work with. And then you can take an algorithm once again and not just apply it to a single image, but you can map it efficiently over a large amount of images. And that's how we're going to go today, applying these algorithms to like all of the images over the United States for a year or something like that. We're going to do this type of mapping and algorithm over a collection. In addition, once you have a large collection of images or vectors or any other collection you have, you might want to reduce it down in space or time. So we're going to go through different ways to do some reductions. And I'm going to point you to the docs, and you'll realize how flexible, I guess, Earth Engine is, because we're going to like pick just like 1 or 2 ways to reduce out of the, maybe 20 to 30 different reducers that we have. We're just going to do some of the more simple reducers in here. But I believe there's a whole nother class in the 102B that they're going into detail on, like what all the reducers are. But that's a very important part, I think, of Earth Engine. It's basically trying to take this big data in some sense and reduce it down into something that you could download and fit on your own machine. And then finally, we'll do some examples of computing aggregate statistics. So like outline an area and count the amount of area that meets a particular criteria, something like that. So you can get it out of the spatial domain and get things more like tabular reports when you're doing these reductions into statistics. Any questions on those before I go forward? Yes?
Can you talk a little bit more about bands and explain the significance of wanting to know information about?
Sure. I'll try to do it just talking right now, but then we're going to go and do it hands-on when we get to it. The concept of an Earth Engine image is that it has 1 or more bands. So we could have an image of elevation for the world. That would be a single band image. But then when you move into something like a satellite, it's collecting different spectral bands. So you might have red, green, blue, near infrared, etc. We can package that into a single image that has multiple bands. The bands don't have to have the same projection. They don't have to share that, same resolution, etc. So it's just a way to encapsulate a collection of related, I don't know if I'd call it channels or something like that, into a single concept called an image. Does that make sense? Okay, and we will definitely be inspecting the bands of an image when we get to that hands-on part. Okay. The other thing I wanted to point out in these slides is that we have 2 computation modes in Earth Engine. And the one we're going to be dealing with almost exclusively is this on-demand computation, that you say, hey, I want to get the result here for the map I'm looking at, and it goes and tries to generate it right away for you. And you might have to wait a few seconds or something to get it back, but it allows you to do this type of interactive computing where you like change an algorithm and you run it and you see the results almost instantaneously. On the other hand, we also have this batch computation. Is like once you've perfected an algorithm and maybe run it on a little area, how about apply it over all of the data for Africa at a certain resolution? That's something you don't want to wait around for. You kind of want to kick off a task and come back and check on it later, because just producing the output files of something like that is going to take hours, if not days, depending on the area and the resolution that you're trying to do it. So just saying that in Earth Engine, you can use the same algorithm in both of these modes. You usually develop them interactively, but if you want to kick off a large job, then you're going to do it in a batch process.
Quick question, please. So if you do that on-demand computation, and let's say you don't store the intermediate steps, can you always kind of go back and figure out what happened until you get to your final?
As long as you have the script, it's kind of your processing flowchart of how you got to the end result. As long as you save that script, you can rerun it again. That being said, it's kind of interesting that there is not strict reproducibility in Earth Engine because the underlying data may be changing. It's like we keep on adding new Landsat scenes and Sentinel data, and sometimes it's the most recent, and sometimes it might be from 10 years ago that they just pulled it off of disk. So you may get a different result, and that's actually a product of the system, is because we're working with so much data. We allow you to easily rerun processes, but you might not get exactly the same result because things change, and it's good to know that. All right, any other questions on this, like batch versus on-demand? And we're going to do a little bit of batch computation today as well. It's going to be pretty limited, but I just wanted you to know that you can do both for images and image collections and vectors and all of these. Okay. All right, so that is the kind of going through the overview. Once again, as we're going through the hands-on, if there's something that you're struggling with from the overview section, we can stop and talk about that as well. Now I wanted to go through the initial setup so everybody can get hands-on with Earth Engine. So we have a couple of steps here. First is you need a Google account in order to access the service. So hopefully if you made it here, at this point along the way, you've got a Google account at some point. The second step up there is that account needs to be registered to access Earth Engine. And we have a largely automated process there, but if you haven't used Earth Engine before, you need to go to that URL, earthengine.google.com/signup, and register the particular Google account you want to have access to Earth Engine. If you use multiple Google accounts, I would say for confusion or lack of confusion purposes, don't do that for this workshop. So basically close out of all of your Google accounts and then open maybe even like an incognito window so you can control exactly the account that you're using. Because sometimes that leads to confusion if you have multiple Google accounts that you have access to. So who has not registered for Earth Engine? All right, so we're gonna spend about 5 minutes or so just making sure that we get everybody through the process. If you are in that boat of trying to register right now, please raise your hand up and we will come around and try to help you. Or if you have any, especially if you need to get stuck at any point, please raise your hand and we will do that. And for those of you that do think that you're registered, try to jump down to steps 3 and 4 and open up that link, because that will show you whether it worked successfully. And if you don't get all the way through number 4, seeing a code editor view, that code editor interface, then raise your hand as well. No, it's to avoid the question was, is the incognito window used just to avoid the logging in issues? And yes, if you have multiple Google accounts, it might get confusing. It might be trying to use a different account. So it's to... No. If you only have a single account, or actually, you can try it without an incognito account, and if it works, great. But usually when I have like 50 or 60 people, then it's safer to use the incognito window. So the end result should look something like this, that you will have over in your scripts tab, which is the upper left here, a list of scripts where it has opened up a account here. In this case, I'm the writer because I'm somebody that has write access to this. It's probably under the reader tab in yours as well. But it should say users Tyler E, that's me, G4G 18-EE101. So it's a collection of scripts that we are going to use. Or I should say you don't have to use these. These are just if you fall behind, you're going to be able to click on this and catch up. If you want to be typing everything in, if you learn better that way, then I'd encourage you just to type along as I'm explaining things. Okay, so I am going to proceed further because it looks like we have everybody that's able to get into the code editor. But once again, keep raising your hands if you fall behind at all. So as I said, this list of scripts here, we have 0 through 16 with 13B in there. So we have about 18 scripts, not numbered as well as it could, I guess, over on the side. But we're going to largely go through these, for the most part, typing things in. But the first one is just about JavaScript syntax. And this was a little bit too much to type. So I would invite you to click on that script that starts with the 0-JavaScript over there on the side. And I am going to try to make this a little bit larger. Give myself some more real estate here. And so the first thing I want to do is just kind of go through a little of the peculiarities of JavaScript, so that if you're not a JavaScript programmer, I want to give you at least enough information to try to decipher what you're typing in there. We're not using anything that advanced in JavaScript, but you need to know some of the key syntax. So just out of curiosity, who actually does program in JavaScript or has in the past? So we got, I don't know, 15, 20% maybe. All right. Who does program in some language? Okay, now we're getting over 50%. And of that language, what is it? R. Okay. R SAS. All right, we don't have an R interface, although we get asked for that quite often. Sorry?
There's similarities with SAS.
Similarities with SAS, okay. I think as long as you have tried programming in some language, this is going to be easy to learn. But we do have to...
Quick question. So, what is there going to be a big benefit of using Python versus JavaScript? Are they?
The question is there a big benefit of using Python versus JavaScript? Is one, if you use JavaScript, you get to use this editor, which is a big advantage. If you use Python, it can be quite flexible, but you are responsible for largely setting up your own environment. In this case, you don't have to do that. And if you really are into Python, I'll be teaching a Python course tomorrow on here. But it's not going to be an introduction to Earth Engine. It's an introduction to the Python interface because that takes a full 90 minutes to go through. And we're going to get through a lot of the concepts here that we won't touch in the Python course. Yep. All right, so key things I want to point out here in JavaScript. If you have 2 slashes at the beginning of a line, that means it's a comment. If I get rid of those, then it's no longer green. It's trying to figure out that it's code. But if you do 2 slashes there, it doesn't even have to be at the beginning of the line. Anytime you start with 2 slashes, the rest of the line is a comment. The next one is if you have multi-line comments, you can do this /* end it with */. It also turns it green, the editor here, so you know that's being interpreted as a comment. We're going to be declaring a lot of JavaScript variables, and those are declared with this keyword here, var. This is something that you don't see when you go to the Python API because you don't need to do that in Python, but var just means we're declaring a JavaScript variable. And then in this case, the variable's name is the_answer, and it equals 42. It might be a string, might be something else. You're putting something into that variable. And then at the end of a statement, we'll do a semicolon to just say this is the end of the statement. If you don't do that, it puts in a little I here as information saying you're missing a semicolon. Your code will still work, but I always like to try to clean up all mine so I get rid of as many of the errors and information notices on the side. In addition, you can do strings. They can start with a single quote, end with a single quote, or you can switch those and do double quotes at the start and the end. And so if you're trying to have a string with a single quote, you should use double quotes around the string and vice versa. You can mix and match is what I'm saying, but they have to, the start and the end have to match. The single quotes or double quotes, but they're equivalent in JavaScript. I already went through this one. Basically, we want to end these with a semicolon. Parentheses are ways to pass parameters into functions, whether it's a built-in JavaScript function or a function that you wrote. And so in this case, I am going to try printing something that said this string will print in the console tab. In order to get this to execute, you have to click on run. And when I click on run, it's not just the line that I've highlighted, unlike some other editors, it's the whole script. So you can click run if you want, and you'll start getting some output over on the side. And the first line of output that says this string will print in the console tab is right here. And in the output tab, we have some different views. I mean, we try to render it as well as we can, like in this case as a string. But if you really want to know what it is, you could click on the JSON tab to see. We basically have objects that have more complex representations. But in this case, these are all pretty much simple strings that we're outputting to the side. All right, next is the concept of lists of items, and those are designated with these square brackets. So a starting square bracket, ending square bracket. So I have a list of 3 items, and then I can reference an item in the list by once again using square brackets and saying I want the 0 item because it starts at 0, confusingly for some people, but it's very common in many languages. I want to look at my list item 0, which is eggplant, and that's why eggplant printed over on the side. So that's how you construct a list and how you access something in a list. In addition to lists, there is the concept of having dictionaries, which is key value pairs in this case there would be 3 keys and 3 values. So in my dictionary, I have a key called food, and that food is referring to bread. I have a color that's red and a number that's 42. And in this case, you still use square brackets, but then the name of the key, or basically the string for the key, in order to reference that item of the dictionary. So my dict brackets with the string color is going to print out red over here on the side, as an example. There's also an alternative notation in JavaScript that if you're trying to get something out of a dictionary, you can just say dot color, and it's a little bit faster sometimes to write it out that way, and can be, but it gets you the same result. The information up here, over here on the side, if I go again, it gives you some helpful information. The editor is saying, hey, this could be written in dot notation. So there's, our editor is trying to help you out, and most of the time it's helpful advice. Not always, but you can use that for hints over on the sides. All right. And then lastly, we need to go over the concept of a function, or how you write a function in JavaScript. Is we're going to declare, once again, a variable of a certain name, but then this variable is going to be a function with some type of input. In this case, it's expecting something that's going to be called string, and within the brackets here, whoops, got a little away from you right there. Within the brackets here, it's some code that it's going to operate on. It's going to use that string, and then it's going to basically do some operations on that string that's being passed in, and then return something to whatever called the function. So in this case, my hello function, that's the name of the function, is being passed in a string that is world, and then it's going to return a string hello plus the string that was passed in plus an exclamation point. So if you look at the output over here on the side, it says hello world was the result of that function. When we get to the functions in an hour or so, we'll go through this again. But that's the general concept of it, is that you're declaring something that accepts an input and then does something with the input and returns a result. And we are going to be doing that a lot with accepting images and doing something with the image and returning a resulting image. Any questions on the JavaScript syntax? Yes?
Is there a way just to run one line of code at a time? You said run lines the whole.
Yeah, the question was, is there a way to run one line of code at a time? In general, I say no, but I will show you a nice shortcut that if I highlight a lot of this and say, hey, I want to comment it out, everything except one line, then I can do it. So not really. I mean, it's all or nothing, basically, is the way that it runs. So it's different than other editors that you may have come across before. Yep. Oh, actually, I should highlight here under the Help tab, there's this useful shortcuts list. And if you find yourself wondering how I'm doing something quickly and I didn't talk about it, it's probably because it's in here and I shouldn't be doing that. But what I just did is command, right here, command / comments or uncommented section. So there's, I would say at the beginning you don't really need to worry about these, but as you use the editor more and more, you want to probably learn some of these keystrokes. It just makes you faster when you're doing your coding. And I use this one a lot, the comment and uncommenting selections, because of that very reason that you have to control exactly what code is being run. Any other questions?
It's not case sensitive, is it?
There are different aspects of Earth Engine that are case sensitive, yes. There are different, yeah, it depends on the language that you're using to write it and the objects and methods of Earth Engine. But in general, yes, it is case sensitive when you're running something against Earth Engine. In here, it's all JavaScript. It has nothing to do with Earth Engine at this point. But the way you can test that out too for JavaScript is like maybe I'll make the function string down here and it says string is not defined the scope. It is case sensitive. Yep.
Is there any way to conserve quickly for example, you have function variable, I don't know how to call this in Java, but is there any way that I can easily consult how to use them?
Okay, the question is how do you consult how to use these functions? And I would say for the JavaScript ones, no, but when we get into the Earth Engine ones, yes.
Okay.
But just since we haven't got to that point yet, I will point out there's a Docs tab over here on the side. This is documentation for Earth Engine objects and methods, not generally for JavaScript. So any of these that are prefixed with EE dot, like algorithms, arrays, probably images are a very good example. These are all Earth Engine image object and methods. So there's a constructor And then there's all kinds of things you can do with the Earth Engine image. So the docs are there. There is also some shortcuts to get to that. We'll get to that as we go through the coding as well. But a lot of the documentation is right there on the left-hand side for individual objects and methods. If you want documentation more on the, let me go here, user guide, of the overall concepts that we'll be talking about in Earth Engine. Whew, that's small. All right, make that bigger. There is a whole API developers documentation that's available, so you can read about what is an image or a collection of image, and it'll have more concepts rather than individual objects and methods. But the way I got to that is under the help up here. There is a user guide. Help forum is a kind of a free-form Google group where you can ask questions of anybody who is also subscribed to that group. So it's a great way to just get discussion started on Earth Engine questions as well. Yeah, I won't go through the rest of those in there, but there's a bunch under help of ways to gather more information. All right, we will move forward to the next one. So at this point, I would invite you to go under the Reset tab up here and just say Clear Script. So we're going to start with a blank slate. And what I'm going to start doing is working my way through these scripts, examples on the side, but I'm going to largely be doing that just by typing in things. So we're going to start off with calling a JavaScript function called print, and we're going to say, hello, world. Get it to run. Our print command, when we do this, it's going to print to the console over on the side. So that is our first code editor script that we wrote running, if you get that to work. Not too exciting. Okay, we have a question on it. Great.
Yes. I was just wondering if there was a shortcut for run. It's like Control Enter or where the shortcuts are. Okay.
Help. Shortcuts. Control Enter is run script.
Thank you.
Yep, sure. All right, the next one is, we're going to go forward beyond the hello world. So the next one, we're going to use the search panel at the top to search for some data that we might want to display. And we're going to start with a image asset that's pretty simple, as a single band image asset. And we're going to move to things that are more complex in the future. So if we search for, I'm going to tell you sort of how to get there quickly. SRTM, and then if you really want to narrow it down, 30 meters. This is a global, for the most part, it's missing the poles, but a digital elevation data set that has 30-meter spacing, approximately, called SRTM 30. If I click on that, I can search for it. I can get a list of the things that might, the top 5. But then I can also click on any of those entries to read a larger description of the data set. And in this case, it will give you a little bit of information. Most time we'll do a paragraph or two just describing the data set. And then very key, over on the side, we will have links to the provider because they will have a lot of more details than we're going to encapsulate into this short description of the data set. Underneath our overview paragraphs, we generally will have a table of the bands, and in this case there's a single band in there. His name is elevation. It has units of meters. And then there will be additional information at the bottom. If the provider wanted certain terms of use for how the data set can be used, we echo it there. Citations, etc. We're trying to give you pointers to go and find additional information on this data set. We're trying to keep it pretty small as well. If this looks like a good data set that you want to use, you can click on import. I see a question there.
I'm just seeing here that in other parts of Earth Engine you call them images, and here you're calling them rasters. Are there any sort of subtle differences between, like, an image, a specific object that's like a special format for Earth Engine?
So the concept of an image in Earth Engine is that it's a regular gridded raster. So it's a particular type of raster. It doesn't have irregular grid. So I guess sometimes I may use them interchangeably. But that being said, it's important to know that we do have a specific data type that fits into an image. and not all rasters may fit in there.
Images could be saved as geotiffs.
Yes. Yep. Images can be saved as geotiffs. That's one of the export formats that we support. All right, so I'm going to click on import here. Actually, before I do, one of the other key points on this data description page is the ID. In this case, it's an image ID, but you might have an image collection ID. And this is the unique identifier that you can use to reference this image, or in the case of image collection, a whole collection of images.
And
So
that version of the image, or just that?
that version of the image.
It gets updated.
Oh, if it gets updated, you won't see it in here, but there's a way to look at the version of the image as well, which when you start talking about satellite images that are processed by a government entity, yes, there will be different versions of it. Sometimes we will make a whole new collection and put in the new versions. Other times we are just updating individual images. It really depends on the data provider and how they make those changes accessible. But that is a really hard thing for us to get a handle on, even within the Earth Engine, is just the different ways that upstream providers make modifications and improvements, and how do we convey that into our data catalog. Okay, so at the end of all of this, I hit import, and I now have a new section at the top of my script that's called imports, and it's a list of variables that I have imported in. So you can rename them. I'm going to take the default name of image and call it srtm. And if you want to go back and revisit what this one is later on, there's a hyperlink that allows you to bring up that data description page if you want. Oops, I'm zoomed up way too large to be able to close that. Okay. But now I have a variable that my script can work with. So one thing I can do is I can replace my string there with srtm, that variable that refers to an image object, and then run it again. And now in this case, what I get over in the console is a little bit more complex. It's the start of a tree for this image object, and as I expand that out, I get some more attributes. It's of type image, it has a particular ID, it has a particular version. This version, which is really long, refers to microseconds past the epoch. We have some way to translation into time within there, but basically it's referring to time in a really detailed way. All right, underneath bands, you can see that there is a single band in here, band 0. It is elevation. It has a particular projection, 4326. There's a way to encapsulate, what a coordinate reference system is, and we recognize these European Petroleum, I always forget what the SG is, but anyway, there's a way to encapsulate what these projections are, and we are using 4326, which is just geographic data, and then there's ways to transform those projections, etc. All of this is kept, is stored for that particular band, and as I said before, an image may have bands that have different projections, but that'll be encapsulated in there as well. So that was under bands. There is also a properties tab here where you will have one or more properties. It looks like there's a lot of HTML sort of that's in there. You have the provider, URL. When you get into the remote sensing imagery from like Landsat or Sentinel, you're probably going to have like 100 of these metadata values within there. They're very detailed about what an image represents, like when it was processed, which processing software, etc. All of that is accessible by your scripts. Because it's stored with the image object. Yes?
Date range, how is that set up?
Where is the date range? Oh, date range in here.
2007, but I don't see a 2007 within the date range.
So the date range here, once again, this is, it's a time conversion. There's a way that you have to take this number and convert it into a time, and it's going to be a date range from the beginning to the end of probably when SRTM flew, if I remember correctly. So it's going to be, it sort of represents data about this time interval, like when the SRTM instrument was flying.
Okay. And you have can you provide that conversion or something for us?
Yes, or maybe one of a TA could find it in the docs. I don't know where it is off the top of my head right now. But yeah, and in the script that you want to do to convert it is different in JavaScript than it is in Python. Just the way the date and time objects work differently in those different languages. But one thing that's kind of important to note is that, especially when you're looking at the documentation here, the EE dot, and when you're seeing time represented as these like microseconds, it's because behind the scenes, Earth Engine doesn't know anything about JavaScript and it doesn't know anything about Python. And in the future, we might add another language like R, which we're not working on right now. But it gives us the ability to basically work with the very same objects and methods from a variety of language, potentially. And that's why sometimes there's a little bit of work of converting it into the native form of the language, like for these time and date objects. Okay, so that is, actually, excuse me for 1 sec. Break out my cheat sheet because I changed some of the things I want to go through today. All right. So there's, actually, the next thing we might want to do instead of just printing out an object. Okay, we have a question?
You say that this is a JSON object, but I'm trying to print strtm.type is give me undefined here. Right?
So,
It's an object.
Yep.
So it's.
Is that what you're trying to do?
I could print
Okay.
strtm.type, no?
So this, at this point, I'm trying to figure out what exactly, is that what you're doing? I mean, are you trying to use a JavaScript function called type? Or?
Just type the field type.
Oh.
Yeah, .type.
Dot type.
Yeah.
Okay. All right, so if you just did it like that, it's going to say undefined because that is a property. But if you want to make a method out of it, you have to do parentheses on it. So that wasn't the confusion either. Let me see what you're trying to do. Is type something that you found in here, or was it?
It's in the properties of the image if you.
Oh, I see. Got it. Yeah. Okay. Now I'm understanding here. If we printed it out and you're looking for the type there, some of the things in there like ID is not necessarily. Yeah, so ID might be the same within here. I don't remember whether we hooked this up. This is a property of the, how do I say this? This is a property of the object that we've exposed here, or a method of the object. And in this case, it doesn't understand that method, how to put it out there. I will have to get back to you if you do want to actually figure out the type of it. I don't know off the top of the head the syntax that you would use for it right there.
I think it's related with these objects doesn't have in the browser. Yeah, because strtm is an object. It's not in the browser. It's like.
It's a browser. Yeah, it's an object on the server. That is correct. Yes. Yep.
Yeah, that's. I want to understand better the differentiate.
Okay. I will point you to the how to understand that better, but we're not going to go through it too much in detail. So there is a section in our documentation called client versus server. And the whole purpose of this is to go through that concept of like what happens on the client, what happens on the server. And if you understand this, you can be a power user of Earth Engine. If not, it trips you up, and it will trip advanced users up as well. But if you figure out how to leverage this, you can do amazing things with Earth Engine, getting both the best of the back end and the best of the front end as well. Okay, that little diversion, we'll be back here. All right, so instead of printing, what I was going to show you next is down here at the bottom of our list of things that you can do with the documentation. After we get through all the ones that are prefixed by EE dot, there is a couple things that are particular to the code editor that we're using right here. And one of them is map, and there is map.addLayer. So we can use one of the built-in objects and methods, map.addLayer, to add SRTM layer to the map. And we get this wonderful bland gray thing by default. But we can produce global bland gray things if you zoom out a little bit. And the reason it looks this way is that it doesn't know how to map at this point the lower end of elevation and the upper end of elevation in a way that actually makes sense for looking at it. So we're going to have to provide a little bit more information to it. And so what I'm going to do is I'm actually going to backtrack up a little bit and show off, one of these shortcuts. I did that a little bit too fast, so let me back that up. If I type out map.addLayer here, or even if I back up a little bit and I just have map.add and I do control space, it's going to try to auto-complete it. So if I go back far enough and do control space, it's going to give me a list of all of the things I can do with a map object. And in this case, I want to use the second one there, map add layer, which I could, start typing in and do control space eventually, and it's going to give me all the options I have for that. But I want to do map.add layer. And if I finish the name of the method like I did right up there, and then hit control space again, it's going to populate it with all of the different parameters that I can pass to map.addLayer. And the first one of those is EE object, which is short for an Earth Engine object. So any objects that we've created before, like this image object, SRTM, we could put into the first parameter. So I can replace that with SRTM. And then I'm going to get rid of all the rest of the parameters because we're just going to use the defaults. And then hit run there. So that's what we did before. And if we want to, the second parameter is visparams, visualization parameters. And so this is the way that we're going to control how it looks. So let me do a little bit of things here. I'm going to put these on different lines for a second here. In JavaScript, it will just interpret it all until it thinks it's come up with a full statement, so I can separate these on different lines. And then I'm going to comment out some of these lines. So once again, my command / is a way that I can comment things out quickly. And now I have an Earth Engine object and visparams, so I could do SRTM for my Earth Engine object. And then under visparams, we're going to pass in a dictionary, a JavaScript dictionary, that describes some of the parameters that we want to use for the visualization. So in this case, I could start my dictionary with the curly bracket, start and stop. And then we can say for a minimum value, and you have a little bit of flexibility in JavaScript of like you can quote the keyword or not. So I'm going to, I guess not, we'll do minimum colon, and then we want to put our value for the lower end of elevation, which I'm going to put 0. There might be some below 0 values, I guess, for certain parts of the world, but 0 is kind of a good starting point for elevation. And then we're also going to put an upper end. Remember that this data is in meters. So we can do 1,000 meters or 3,000 meters, or if we're going to the Himalaya, we want to go up to 8,000 meters. Whoops. And then I get my error here. The reason I believe it did that is I had an extra comma. All right, so far I've just plugged in 2 of the parameters to add layer, SRTM, and then visualization parameters. I can go a little bit further and specify like a name if I want, because by default, if I go on my map and look under the layers list, it just says layer 1, which is okay if you have a single layer, but when you get a lot of them, that can start to be confusing. So for my name down here, I'm going to say SRTM. And then I have to go back in that preceding line, make a comma, so it knows it's a list of these parameters, or it's a third parameter. I can run it again, and underneath layers, it's now entitled SRTM. So now you know if you want to manipulate that layer, like change the opacity or something, turn it on and off, you know which layer that you're operating on. And then there's a couple of other parameters that I'm not going to get into right now. Is shown is by default, is it turned on or off? By default it is shown, but you can make that false and have it start off invisible. And then opacity is if you want to control the initial opacity or the of the image that you're overlaying, you might set that. And that tends to be more of a special case. Most of the time you want it to be full opacity with there. So I'm going to clean up a little bit now that we've added our 3 parameters to bring that all back to one line here at the top. And boom. And then run it again. Make sure it works. You'll notice this pattern that I use a lot is like make a few changes and then hit run right away, because then you know if you've broken something along the way. And because it's so inexpensive to keep running these operations, just keep hitting run all the time to make sure that it's still working. Yep.
Is it because this has one band that it knew to just map that layer? If you had several bands, you have to tell it which one you want?
Yes, the question is, well, it was a good comment, basically. Yes, the reason that I didn't have to tell which bands to map is that there's only one band. So it will either map the first band, or if there's 3 or more bands, it will map the first 3 bands as red, green, and blue channels. In this case, there's a single band, so it defaults to using that band and does basically a grayscale mapping. I just, at this point, modified the upper and lower bounds of that mapping. If we wanted to do something that was more colorful, we could say palette. And then maybe we go from, I don't know, yellow. This is going to be terrible. Purple. And then that's our map of the world. You can do things that are a lot more complex than that as well. And there's all kinds of different sort of like stretches, gamma stretches that you can do as well, setting different parameters in there, gain and bias. I would, if you're curious about that, just look under visualization parameters in our documentation. All right, I'm going to get rid of the yellow and purple. Yes?
So here I see you defined palette, you just
Oh.
say yellow.
Yep.
So it means, for example, before that you have min, max. So can we just say range? Do we have such option? Like you just define palette and 2 means from low to high.
So the way that the default works for the palette, or the way the palette works, is that it assigns the first to the lowest, the last to the upper, and then it interpolates in between. So I could have put additional ones in here. Blue, gray. Actually, I'm not sure if I spelled gray right according to this, but there we go. And it will basically do interpolation from the min to the max.
Yeah, but I mean, in terms of, for example, in terms of values, we have 0 to 1000.
Yep.
Can we do similar thing? Instead of defining min, max, we can have just like set up in one command for range.
Oh, so I'm not sure if this is what you're asking, but there is a language called style layer descriptors. And I'm going to look in our documentation right now for image visualization. And there's a whole section in there that allows you to make these intervals and ranges. It's a whole language for styling that type of color maps, I guess, for a lack of another word here. So you can do a lot more complex things with mapping values to colors in multiple bands. That's where I would direct you to. But I get the sense I'm not actually answering your question, so I'm not understanding the full question. Okay. All right. We'll discuss it later. But yeah, if you're curious about advanced styling, there's a whole image visualization section in our documentation that will walk you through that. Okay. So let's get rid of my psychedelic palette. We'll run that again. And now let's add another layer to this. So I'm going to have you search again up at the top for a particular image. And this one is called Global Surface Water. It'll take a little while for it to like search through the catalog. And if it takes too long, then I'll search for something else. JRC. All right. So there is a raster here called JRC Global Surface Water Mapping Layers, version 1.0. And that's the one that I want you to, you can look at and see like the definition of it is the European Commission and Joint Research Center is the one that generated this data set. It has more than one band, although we're just going to be selecting out a particular one, which is the percent occurrence of water is the one that we're going to use. But there's a lot more information within this data set than there was for the simple elevation. But just the same as before, we can import this in, and then I'm going to rename the object water. And in order to get that to display, we're going to add another map.addLayer command. And then we can put in there water. This time we are going to have to specify the bands because there's more than one of them that's in there. So I'm going to say in my visualization parameters bands, colon, and then I'm only going to specify a single one of them for this. But occurrence, and this is expressed as values between 0 and 100%. So we'll do a min, start off of 0, max of 100. And then, let's see, what else do we want to add on there? I guess we'll just add a name at the end. Water. And then I'm going to just run to see if it produces something other than an error. Okay, so it didn't come back with an error. But right now it's not very watercolored. So let me try to add a palette as well to here. And actually, to make this easier to see, I'm going to use some extra lines in here. We will go from light blue to blue for our palette. And then I'm going to zoom in to something that is not global. One of my favorite places to go for testing a lot of these things is the Grand Canyon, because it has some really nice relief. There's a little bit of water there as well. So if I go in there, I can see that my visualization parameters for elevation aren't the best because a lot of that's over 1,000 meters. So let me up that to 3,000. All right, that's looking a little bit more what I'd expect. All right, so at this point we have two layers. If I put my cursor over the layers list in the map, we have water and SRTM. And the water one is kind of interesting. If I scroll around here until we get to like one of the reservoirs. A little reservoir. Oh, there we go. Once I get down to the reservoir, at the lower end of the Grand Canyon, you'll see this coloring that it's not all dark blue. And that's because this is sort of like an area that sometimes during a flood there'll be water. It depends on the reservoir level. There's fluctuations, so it's not water there all the time. And if we want to kind of compare that to the underlying satellite imagery, we can. So I'm going to turn off both of my Earth Engine layers, and then for the base map, we can click on satellite. And then I'm going to zoom in a little bit and see what it looks like down there. So we can see, I guess, vegetation on the side. If I turn on water once again, okay, sometimes it's saying that vegetation on the side is flooded. So probably from a fluctuating water level. But it's often very useful to go to the underlying satellite imagery just to get a reference of like what you're looking at and see if you can understand why it's behaving a certain way.
Do you mind expanding your codes part a bit?
Yeah, sorry for covering that one up. Okay, we are almost into 90 minutes, so we're going to finish up this section, and then we're going to come back for the second 90 minutes. Is that right? Are we through? All right, maybe we'll push on through the next little section maybe before we do the break. All right, any question? Oh, we got a question on that. Yep.
I'm having some trouble just to understand the parameters. Actually, I didn't understand exactly what they mean.
Okay,
The
so
second parameter, the scale, min, max.
yeah, so I'm going to go over here on the side to our docs tab.
Yeah.
And then the one that we're running right now is map add layer. Sorry, that went off the screen, I realize. Try that again. There we go. All right, so the first parameter is EE object. That's some type of object we're going to display on the map. The second one is viz parameters, and it says for images and image collections, see EE data get map ID for valid parameters. So there is a whole language there that is trying to tell you to go look. In this case, it's referring yet to another command, EE data get map data. So let's go look at that. Where's my EE data? There it is. EE data. It's a little bit confusing because this is a lowercase, so it occurred after in the list. And get map ID here. Now it starts talking about all the parameters that you can pass in here. So it has min, max, there's a gain, bias. You can apply it to one band or multiple bands, opacity format. So there's a bunch of things that can be in there. And then if we go all the way into the help documentation, there's going to be some concrete examples of using different ones. But in general, the ones that you want to be using are bands, min, and max. Those are the basic ones. And that's what I'm using over here right now. Bands, min, max. Actually, I guess palette as well. Is that one in there? Yeah, palette down there.
I'm just wondering the min and max, how do I define them?
Oh, okay.
What do you refer to?
Okay. All right, I understand more now. The question is like, what are the min and the max referencing in here? And we are basically trying to establish a way that the data that we're displaying is mapped into certain colors. And in the case of SRTM, we are saying for the minimum value we're considering, or the minimum color will be associated with 0 elevation. The maximum color will be associated with 3,000. So you're going to see a gradation of color anywhere between 0 and 3,000 meters. Once you get above 3,000 meters, it's going to be totally saturated. I mean, it's not going to change anymore, which is what I was seeing when I did 1,000 meters of elevation here and ran it. Everything was white because it's above 1,000 meters. There's some other tools that you can use for inspecting values. It's called the inspector in the upper right. So if you go on the inspector tab there and then click on the map, it's going to start giving you information about where you clicked. And in this case, I clicked on an area where the elevation was 1,349, so it is above that 1,000 meters. And then it's going to give you, in the case of water, a bunch of information. However, in this case, it's all masked out because this image, we're masking all areas out where it's never water. But if I clicked, for example, down in where you got some blue information there, then you're going to see some actual values for water. So that's the inspector. That part is called the pixel inspector. There's also a whole nother section down here called objects, and this is going to give you, once again, the band information for whatever objects you clicked on. But cool. Pixel inspector is very useful, yes.
Would they inspect like the environmental variable list, like everything that's in the environment, like a state there? Like if you need to remember what you've already named.
So when you click on it, whatever has been added as a layer to the map is what is going to occur there. Yep. Oh, I'm not a user of RStudio, so I don't know. um, but one thing that's actually useful quite often is that I will add layers up here, and then I will say false for the visibility, because I don't want to see them, but I still want to be able to inspect their values. And they still appear on the inspector list, even though they're not displayed by default on the map. Yeah. You can have it, yeah, in there without showing up on your map in this case. I should point out too is like all this information you get out of the inspector, you could do with code too. It's nice to have a GUI tool to do the same thing. Okay, so that was my false there.
Can I ask a quick question?
Yep.
I think scroll on the center console or the code. Scroll to the right. Keep on going.
Yep.
I'm seeing the little eye icon. Yeah, those little eye icon at the end of the code there. Each line. You click on that where the.
Oh, this eye.
Yeah.
Okay.
So, that's something. The other one turns on like all 7 bands on the image.
Interesting. I don't use that very often. Within there.
Yeah, toggle on like all 7 and then.
Yeah.
On the map, yeah. Okay.
Okay. So we are going to. So congratulations, we've made it to step 2 out of 16. But it actually has been a lot of good discussion about this. So. Yeah, but I'm being a taskmaster when I go through it in about 90 minutes. Okay, so we're gonna do a coffee break, and we're gonna come back here in 25 minutes and restart. And yeah, we'll move a little faster after this. But also be aware that all of the scripts are in there if you need. Cool.